Okay, so we've reached the final level of the Blockley maze. And as you know, since it's the last level, this level is actually very difficult compared to the other levels. So I would suggest that you try it on your own first, and you only refer to this video if you really do not know how to solve it. Alright? Because my method is not the best method. Alright? It's kind of brute force. And I'll show you what I mean in a bit. So if you can, try to solve it on your own first, like attempt to solve it, because this maze really challenges your logical thinking. Alright, so let's get right into it. So first of all, I would go forward. Okay, and then I will be turning to the left. Alright, for sure. And then I will move forward again. And when I reach this intersection, of course, I would prefer to turn right, because that's the fastest way to get there. Alright, then once again, I'll be moving forward, and then I'll turn left inside here. We wouldn't want to end up at this dead end. We turn left, and then go forward again. Once again, we will turn left at this two-way path thingy. Then move forward. We're gonna turn right. Okay, move forward to the end. But before that, we're gonna turn right. Okay, so this is kind of how it looks like the most ideal path. Okay, on the surface, you know, it's pretty straightforward if you're the person, like how would you walk there? But how do we convert this into code? With that, we'll have to try and solve it step by step. Okay, so let's first work on the easiest section. All right, let's work on this part right here, turning left. Of course, we'll add a repeat until. All right, and then we want to move forward. Okay, so let's run it. Of course, it will end up here, right? We will want this guy to turn left if there is a path to the left. Are there any other situations to look out for in this part? No. So we're gonna use if path to the left, then we turn left. Okay? So let's try it out. Alright, so let me stop here. So as you can see, when it reaches this part, we want this guy to turn right. But instead, it checks if there's a path to the left. Okay? So how do you make it so that if you're here, we want to turn right instead of turning left? Alright, before I give the solution, I just want to remind you that in this level, we have limited number of blocks. Alright? Just to let you be aware. So we cannot just like brute force the whole level by just turning manually. So remember, there is this thing called priority. In this case right here, where I'm moving my cursor, which one is more important? Going forward, turning left, or turning right in this section right here, right? Because right here, the case is we can do all three things. So which one is more important? Of course, we will say it's turning right. Okay, so are we supposed to change anything here? Because right now, what it checks first is if you can turn to the left. So let's modify this a little bit. Instead of using if path to the left, turn left, we'll first check if there is a path to the right. All right. So if there's a path to the right, which is in this case, we will turn right. Okay. And if there's no path to the right, which is in right here, we want to turn left. Okay. And you'll notice there will be a problem. Do you see that? It's because over here, after it moves forward, it will go through the if condition to check if there's a path to the right. In this case, it's false, right? And because it's false, it enters this else condition and turns left without even checking. Okay, so the simple fix would just be to put this right here. So if there's no path to the right, then we check if there's a path to the left, which is in this case, it will turn left right here. Okay. Now it turns right here, right? Then over here, turns to the left. Then, oh no, it turns right over here. And we probably will get stuck. Yep. So this is the final part. We've already solved this part where it turns left, turns right, turns left. Here actually works. Okay, and we hit the wall. So let's solve the last section. So we solved the first section. All right, I'm gonna put it in orange, where we turn left. Okay, and indirectly we have also solved this part. All right. Now you might be wondering why, but what I want you guys to see is the pattern. Do you see the way the path is structured here is the same as this? Do you see that? It's because there's no path to the right. Okay, then it turns left because it will check if there's a path to the left, it turns left. Same goes to this part. It turns left when there's no path to the right. Okay, so these two, it works. Okay, you can refer to the code again if you don't really understand what I mean. But our main point is this two. Okay, we've solved this one where we check if there's a path to the right and then it turns right. But let me change the color, blue. In this part, okay, we only want to turn left, not turn right, because if you turn right, it will go here and it gets stuck, right? So how do we make it so that this case, turning left is more important than turning right, while maintaining the fact that right here, turning right is more important? So remember, I talk about patterns, right? This pattern and this pattern are the same. If you look at it closely. They're the same, right? What I mean by the same is here, the turning left part. It turns left because there's nothing below it. There's nothing on the right, so it turns left. Now, I want you guys to take a look at this two. So this part where we have to turn right, okay, because it's the way, and this part where we have to turn left. Okay, how do we make it distinct? Like both of them are unique. The answer is, if you pay really close attention, in this part, when we turn right, there is a path ahead, correct? You see that? There's a path ahead. But at this part, there's no path ahead. Okay, do you get an idea? If you get an idea, that's really good. Now let's come back to the maze that we've been doing. Okay, this part has been solved, so we keep it as it is, which is the turning left. Okay, now remember the pattern I told you about? We wanted to turn right over here and turn left here. So let's use an if-else condition again, okay, because we can now make it distinct. Okay, so remember there's a path ahead. Okay, if there's a path ahead here, we want it to turn right. And else means there's no path ahead. It will do whatever it wants to. So let me just play the code. I'll fast forward the video and we'll end up at that point. Oh yeah, before that, see, there's a path ahead. Then it turns right. Okay, okay, as you can see, it hits the wall, right? Because it enters the else condition. As you can see, it didn't turn right, correct? There's a path to the right, and it checks if there's a path ahead. There's no path ahead. So it enters the else condition. Okay, so let me just add a turn left and fast forward again. You'll see what happened. See, when it enters here, it will turn to the left. All right, let's ignore the rest of the code first. As you can see, it's still not solved yet. But what we have solved is when you reach this part, it checks if there's a path to the right, which is true. Okay, but before it even does anything, it checks another thing. Is there a path ahead? And there's no path ahead, so it turns to the left. All right. Now, as you can see, when you turn to the left and it does some random shenanigans, it continues checking the code and it ends up at a dead end. Now, here's why my answer isn't the best solution. It's because when you turn left here, all right, I have 2 blocks left. What I can do is I can kind of brute force the answer. Okay, so what else is there for me to do? I can turn left, right? I can move forward, and then I can turn right. Okay, as you can see, I ran out of blocks. I can't add anything anymore. But once it does a turn right, it exits this if condition, correct? And it repeats the code where it moves forward to the end. Do you see that? Can you imagine that? Once it reaches here, it turns right, then repeats the loop, it moves forward, and it will go through the if condition again. Now, when you're at the end point, is there a path to the right? No. So it enters the else. Is there a path to the left at the end point? Also no. So it does nothing, and then you win the game. So let's run it. Fast forward again. See? It works. But, of course, my solution isn't the best solution. But if you're a beginner, if you're new to coding, or if you have to somehow do homework for this Blockly maze, and you somehow stumble upon this video, I believe this is the best way and the quote-unquote easier solution for you to understand, because everything here is pretty straightforward, and hopefully my explanation is clear enough. And if you have any questions about this code that I've given, you can always ask in the comments. All right. So yeah, I'll end it here because I'm scared the video will be dragged way too long.